this is the first part of chapter 1.4, and we're going to talk today about the matrices, matrix multiplication, and matrix equation. So how do we multiply matrix by a vector? Let's take a simple matrix, like here, for example, 3 by 3 matrix, and multiply it by the vector of 3 components, and we call these components x1, x2, and x3. And I just using the color coding here to make it easier to you to follow the multiplication process. So basically, we take the first column and multiply it by the first entry of our vector. Then we take the first element of our vector, multiply it by the second column, and the third component of the vector by third column. And that might look familiar to you because it does look like a linear combination of elements of our vector with the columns of our matrix. But okay, if it might be slightly confusing, so let's just try to go through example. For example, we have a matrix here, 3 by 2, and let's just multiply it by the vectors. And again, I will color code it to make it easier to follow. So I use the same colors. And again, we use the first entry of our vector 4 and multiply it by the first pink row. Then we add the second element of our vector 3 multiplied by the second green column. And finally, the third element 7 of our vector multiplied by the third blue column. And now all we just have to do is just conduct scalar multiplication for all 3 terms and then add an appropriate elements together to get the resulting vector. So as you can see, it takes some patience, but it's really, you need to practice it, probably 3-4 examples, but eventually you'll get it right. So, but let's go back to our matrices. Actually, let's just do our new notation. Let's call the first column of the matrix A1, the second A2, and the third one A3. So now, when we are conducting the matrix multiplication, you can see that we can represent our matrix multiplication as a linear combination where our component of our vector are just the weights. And actually we can conduct it for any matrix. So basically if we have a product of our matrix and the vector x, we can use corresponding entries of x as a weight and make a linear combination of those weights on the columns of matrix A. And so we studied last time that when we have a linear combination, we also go and write it down as the system of linear equations. So we basically can go from equations to the systems of equations. Can we go back from system of equations to the matrix? It should be possible. Let's do an example. So here is the system of linear equations, 2 equations, 3 variables. Let's just try to write it down in a matrix form. Okay, we start by isolating the weight for the vector, for the x1. Then we continue with the second element, x2, and just basically isolate our multipliers as a columns. And conduct the same for x3. And again, I'm kind of using the color coding to make it easier for you to combine them together. So finally, the right-hand side, all we do is just put them in a single vector. Okay, that's nice. So how do we form the matrix? Pretty easy. We just put all these 3 vectors right next to each other and put the brackets around it. And we will call it a vector A. and we will multiply it by the row of our column of our variables x1, x2, and x3, and we'll call it a vector x, and the right hand side will remain the same. This is the vector which we call b. So now all this complicated structure we can write down is one very simple equation, ax is equal b, and it's called a matrix equation. And we will study this equation for the rest of the semester. You will probably see 10 million times. And the interesting things about this equation, and it's because we're going back and forth between the matrix equation and system of linear equations and the linear combination, the solution should be the same for all three of them. And more interesting, we can actually try to solve one of them by just forming an augmented matrix consisting of the row of our matrix X and the vector B. Just combine them together, solve it, and you have a solution for all three, for matrix equation and for linear combination. Okay, that's all about matrix equations, and I'll see you in the second part.